Eclipse, Cayenne, Mr. Mask, and Shinigami are all recognisable as belonging to this masked shinobi, but no name brings fear to those who hear it as Kaze, meaning the shadow. Kaze uses stealth, a pair of short swords, and robotic arm to dispatch foes quietly and efficiently, with a small pilot light in his finger turning to a flamethrower when more aggressive measures are needed. Kaze's pilot light is activated by clicking the fingers of the left hand, producing a flame from the tip of the index finger, here simulated using a proof-of-concept mechanical model that requires a second hand to activate. Creating this pilot light as a practical effect has been the main goal of this project, with the production of some armour elements, his mask and sword to contextualise and expand the final outcome. In-universe, these armour components are made from a high-strength carbon nanoweave shell over a ceramic plate mail and regenerative gel body armour base layer, creating a flexible and bullet-resistant pauldron. This blade, sitting proud on the chest, requires no sheath as it is held in place magnetically. It can be removed and replaced with ease and requires no careful alignment. As such, the larger of this pair of blades can be placed on the back, despite not being able to see where it is going. One can feel where the magnets are and the blade will auto-align and secure itself. Writhe Innovation aims to bring the most impressive and accurate props and practical effects to life using new and creative solutions wherever possible, with fresh ideas and IPs ready to go. Writhe holds firmly to the belief that practical effects will age better and produce more timeless and exciting visual effects than CGI. The costume and practical effects market is full of opportunities and competition, with more money than ever going into film budgets. Costume budgets for films can range from $20,000 on the lower end to films like Black Panther, where one suit could cost up to $300,000. On modern Hollywood films, a fifth to half of a film's total budget can often be spent on visual effects, equaling $40 to $100 million plus on a large movie. Initial prototyping for the lighter involved separating the mechanism from the original casing and getting it to work in isolation, replacing wires and 3D printing a housing and lever configuration to have it light with one action. These components were then assembled with a glove and armour segments to create a glove that could produce a flame from the finger as a proof of concept. The proposed method of activating the pilot light with a click then needed to be developed. Using an Arduino, 3 LEDs and 3 pairs of contacts on a rubber work glove showed that the system would work as follows. With the hand open, the red light is on, indicating the system is live. Bringing the fist or index finger closed would complete the first circuit and trip the safety, causing the system to become disabled. Bringing the ring finger to the palm of the hand and completing their circuit turns on the green light, representing the gas lever being pressed and the release of gas. Completing the clicking action and bringing the middle finger down to the base of the thumb then turns on the blue LED, representing the ignition spark. All 3 LEDs are on, showing that a flame would be produced from the finger at this point. If the index finger is not pointed out enough, and the system once again shuts off. Armour prototyping started with origami paper pattern experiments, culminating this curved and flexible sheet. This pattern was then tested with 3D printed triangles and fabric before being made full scale and attached to a shoulder brace. This resulted in a very pleasing and dense looking armour plate that was deceptively light and flexible despite its rigid exterior, perfect for a believable and usable costume. The wiring and component layout here shows the proposed convergence of prototypes for the flame glove, combining the pilot light functionality, Arduino-powered click control, and the armoured visual model. Major changes represented here improve safety, reliability, and convenience. The open pad contacts will be replaced by flex resistors on each finger, removing the exposed electrical contacts and allowing for the exact bending required of each finger to be customised within the Arduino's code. The piezo igniter will be replaced by an arc lighter circuit with a higher power to increase the reliability of lighting and remove the notable force required to depress the piezo switch. The flexible and multi-layered armour used on the shoulder will be altered for the forearm, made by 3D printing a rigid shell and covering it with fabric, so that the electrical and mechanical components of the lighter can be hidden within it, rather than under the sleeve as was previously planned. This can then be easily removed to fix or recharge components.